The next application we want to talk about is a break-even point, or finding the break-even points for a company. There are two ways to go about finding break-even points. A break-even point occurs whenever our revenue, the money that we're bringing in, is exactly equal to our cost, the money that we're paying out. So the result of our business is nothing. We have nothing to show for it. So we can either solve a revenue function set equal to a cost function. When revenue equals cost, we have a break-even point. Or we can solve our profit function set equal to 0, since our profit function is just revenue minus cost. So that would be like subtracting our cost function from both sides here to get r of x minus c of x is equal to 0. In example 5, we're told that below are the price, demand, and total cost functions for the production and sale of a particular product, where x represents the number of items produced and sold in hundreds, and p represents the price per item in dollars. In part A, the first thing that we want to do is find the revenue function, since we need both a revenue and a cost function to find break-even points. To find a revenue function, we take x, units sold, times price, which in this case is the form of our price demand function p of x. So we get x times negative 0.23x plus 16.72, or negative 0.23x squared plus 16.72x once we distribute x through those parentheses. Then we want to use Symbolab to find those break-even points, which again, we can do by solving our revenue function set equal to our cost function, or by taking our profit function set equal to 0. We're not explicitly asked to find a profit function here, but we'll demonstrate how we would go about that. What we would do is enter in our revenue function. Whenever you're in Symbolab, once we start using exponents, you have to press the arrow key or tap or somehow move out of that exponent. So I press the arrow key there to move out of that exponent, plus 16.72x, and then we would subtract our cost function in a set of parentheses to make sure that that subtraction step carries all the way through our cost function. And then Symbolab would take care of that arithmetic for us, the simplification, to give us that profit function. Once we have a profit function, we could set that equal to 0 and solve, or we could solve the revenue function equal to the cost function. Since I already have some of that information typed in, I'm going to take a little bit of a shortcut here and just edit what I had already entered. So now I'm solving my revenue function set equal to my cost function. And that output looks really angry. There's part of the word in my output, so I think it didn't like the way that I typed that in. So let's just go back to the drawing board and we'll type this in again. Sometimes when you go back in and include information that wasn't there, it reads it poorly. So we'll solve negative 0.23x squared plus 16.72x is equal to 1.97x plus 220.56. And those numbers look a lot better. The solution, the exact form is still kind of ugly, but it's giving us these approximate forms which are much nicer, and those are the values that we want to use. So when we solved this, we come up with x is approximately 23.7453, and we got 40.3852. But those values are not our break-even point. Those are the numbers that we want, but we have one last step that we need to take into account here, because we were told that X represents the number of items produced and sold in hundreds. So our last step to answer part B is to multiply both of these results times 100 to get that unit conversion in place. So our break-even points will be at production levels of 2,375 units, rounding that to the nearest whole number since we're talking about units produced, and 4,039. So we'd have break-even points if we're producing 2,375 units or 4,039 units. And then part C asks us to enter a production level that would yield a profit for producing and selling this product. There's not really any math to do for this problem. This is just understanding the concept of what we mean by break-even points. If we were to graph a revenue function and a cost function, we would see that what we're finding are these 2 points where revenue equals cost. If we're to the left of that first point, our revenue is dipping below our cost. If we're to the right of the second point, revenue is dipping below our cost. So what we need to find an area where we're generating profit is anything in this region where our revenue is exceeding our cost. Meaning we just need to pick any value in this interval, and that will be a correct answer. For instance, if we said producing 3,453 units, that production level is within those break-even boundaries, so that would be a production level that would yield us a profit because our revenue at that production level would be larger than our costs.